Hello everyone and welcome to the Curious Calculator. Today we're going to be going over the following problem. Write a polynomial of least degree given the following roots, 1 plus 8i and negative 4i. In order to start this problem, we're going to want to use the complex conjugates theorem, which states that if a polynomial has a complex root of the form a plus bi, then its complex conjugate a minus bi will also be a root. And we can notice here that to get the complex conjugate, what we're doing is we're leaving the we're leaving the real part alone. So the real part would be a in this case, and we don't do anything to that. All we want to do is negate or flip the sign of the imaginary part. Okay, so using that, let's try and find all of the roots of this polynomial. So all roots, let's see, we're given 1 plus 8i, and so we know that 1 minus 8i should also be a root. And then we're given negative 4i, and so 4i should also be a root. Now utilizing these roots, let's write down the factors of the polynomial. So the factors, let's see, we have x minus 1 plus 8i, x minus 1 minus 8i, x plus 4i, and x minus 4i. And just to see why these are the factors, we could say, for example, look at the first one here, the x minus 1 plus 8i. And notice that if we plug in 1 plus 8i, then it'll be 1 plus 8i minus 1 plus 8i, which will give us a 0. And then, for example, for this one over here, the x plus 4i, if we plug in a negative 4i for x, then that would become negative 4i plus 4i, which will again give us 0 in this case. So those are just some little examples of why these are the factors. So let's continue on. I'm going to go ahead and rewrite this a little bit so that the algebra becomes a little bit easier to do. So let's go ahead and let's distribute the negative through this. And I'm going to do the same thing over here. And let's leave these alone. Okay, and now what I'm going to do is I'm going to actually write some parentheses right here. And the reason I'm doing this is because I want to utilize this little property that if we have a plus b times a minus b, then we get a squared minus b squared. And notice that now we can apply that up here, because the way that these are written, this right here would be like my a, this would be like my b, and so I have a minus b and a plus b. And again, over here, this would be like my a, this would be like my b, so it would be a plus b and a minus b. And so we can go ahead and rewrite this as x minus 1 squared minus 8i squared times x squared minus 4i squared. And now this is going to become, let's see here, so we have x minus 1 squared, that's going to be x squared minus 2x plus 1 minus, and then this will be, let's see, 8 squared is 64, and I squared is going to be a negative 1. So let's go ahead, negative 1. Okay. And then this is going to be x squared minus, and 4 squared is 16 times negative 1, because I squared is negative 1. And now I'm going to go ahead and write this as x squared minus 2x plus 1. Now, because we have a negative 64 in here, and we're doing minus, that's actually going to turn into a positive. So we're going to have plus 64 x squared. We have a negative 16 and a minus in front, so that's going to also turn into a positive 16. And this is going to become x squared minus 2x. And then plus 1 and plus 64, that becomes plus 65 times x squared plus 16. And now, when we multiply these together, we're going to get x4 plus 16x squared minus 2x to the third minus 32x plus 65x squared plus 1040. And simplifying that a little bit by combining like terms, we're going to get a final answer of x to the fourth minus 2x to the third plus 81x squared minus 32x plus 1040. And that right there will be our final answer. I'd like to end today's video with a little fun fact from philosophy. Did you know that the philosopher René Descartes is the one who coined the term imaginary for imaginary numbers as a derogatory label, because he didn't really believe that they corresponded to any quantity that actually exists?